So everybody, it seems like every single Computex, we're here at Noctua, and there's a new update about their next generation cooler that everybody's been waiting for. A little bit of a change here. It is not called the D15. Everybody thought it was going to be called the D15. I have Jacob next to me. He is the master of Noctua, of all things Noctua. So he's going to address what the new name is, what its price is, and when we can see it.
I think what you meant to say was D16.
D16.
Because a lot of people assumed it's going to be called D16. But in our naming scheme, the number usually refers to the size. So if it was called D16, it would be 16 centimeter wide, which is not the case. And the official name is going to be D15 G2.
G2. Okay, so what are we looking at for the price?
Price is going to be 149, both Euro and USD. And yeah, the good news that we can bring this year is that sadly it took us a little bit longer than we expected at last year's Computex when we last talked. But we have units in production. Production is in full swing basically. Units are shipping already, and we're targeting late June release date.
So this is another thing that we noticed, that ordering one of these is going to be a little bit more complicated for one main reason, and that's because Noctua has realized that in order to get even more performance out of the D15 G2 than they were initially targeting, we have different surface contact plates. Now, because we have actually been talking about this quite a bit, about how surface contact it's being more and more emphasized by manufacturers because there's such a departure in the different types of CPU IHSs. You don't need a flat base, a one-size-fits-all necessary solution. In order to get the best performance, you need to tailor-make your base plate per solution. So can you talk a little bit more about that?
Absolutely. So the best of it all is that you're not only getting a single D15 G2, you're actually getting 3 of them. I will start with the very simple message first, and that is it's not as complicated as it may seem at first, because there's going to be the standard version that's just going to be called NH-D15 G2. That's going to be the all-round solution that's going to work best for the vast majority of customers. So if you don't bother with all of the stuff we're going to talk about now, just go with this one, you're going to be happy.
And not only that, is because they're going a different route for Intel and AMD. That sort of middle solution allows you to either go with a different platform in the future or stick with that same platform that you're on right now, instead of saying, okay, look, you're going with an Intel-centric design or an AMD-centric design.
Yes, totally. We really did everything we could to make that standard version as versatile as possible. So we're including the offset mounting for AMD, you're already familiar with, and this way you can get state-of-the-art results on AMD. But we're also including shim washers. You have some of them lying here to put underneath your LGA 1700 ILM to reduce CPU deformation due to ILM pressure. And this way you can get perfect results on factory new LGA 1700 CPUs as well.
So I think we need to talk a little bit more about that factory new versus used, but the other thing that I wanted to talk about very, very quickly is the fact that all of this hardware you get in all of the versions. So think about these ILM washers as, I guess, that contact plate that you see from some manufacturers, right? Yep. It's in order to regulate the ILM pressure of your cooler, correct?
Exactly. Yeah, it just reduces the amount of pressure the internal loading mechanism puts onto the CPU, and thereby you will get less deformation.
Exactly. So let's talk a little bit about why and how you accomplish this in basically that dual path approach, with one path going Intel and another path going AMD, especially when it comes not necessarily to older CPUs, but we're talking about the current generation and moving forward as chiplet designs become more and more prevalent in the market.
Yeah, so I mean, the basic problem we're dealing with is that both the contact surface situation, but also the hotspot location situation is drastically different between AM5 and LGA 1700. So AM5 CPUs stay relatively flat. They have a slight deformation when you close the socket actuation mechanism, as it's called with AMD. But the deformation, you can see it up there on this flatness scan here, is mainly limited to the outer areas where the SAM presses onto the CPU, but the main contact area remains relatively flat, and this is why we can generally get very good results with flat CPU bases on AMD, whereas with Intel, with full ILM pressure, we have a massive amount of deformation due to that ILM pressure warping the CPU. So we're dealing with different scenarios, and with AMD, we also have the CCD shifted towards the south side of the socket. So with AMD, the situation in the end is that you can either go with a relatively flat cooler, so that would be the low base convexity version of the NH-D15 G2. This will give you a nice uniform contact patch, good pressure over the CCDs, good pressure over the iodide. So you're also going to have good iodide temperatures, or go the other way, using, for example, a mid-convexity heatsink. So that's basically the same as all our existing multi-socket coolers and the same as the standard version of the NH-D15 G2. Use the offset mounting, shift the pressure pattern over the CCDs, and you will have excellent results there.
So Intel is a very different approach right now. They haven't necessarily moved to a chiplet design with their current CPUs, but it's why we're seeing our own testing vary so differently from AMD to Intel. On one hand, you've got a cooler that does very good on Intel that might not do as good, at least in competitive analysis testing, on AMD, and vice versa. The charts are very, very different. So explain where we are now with an Intel-centric cooler and why you might not want to use that AMD-focused cooler on Intel.
Yeah, I think the pressure scans make this very obvious, because we already talked about the nice contact we get with a low base convexity heatsink on AMD. And if we put the same heatsink on Intel with full ILM pressure, we can see that there's some contact on the north and the south side of the IHS, but no contact whatsoever over the die where it really matters. And even if you use washers or a contact frame to reduce ILM pressure, you'll still have centralized pressure in the north and south region. So even then, we have the performance data down there. A low base convexity heatsink is simply not going to do great on Intel.
So you need the high base convexity.
Yes, exactly. That's where the high base convexity version steps in with full ILM pressure and a relatively fresh CPU. So we have to talk about deformation over time as well in a minute. You will have very nice centralized pressure where it matters the most, over the hotspot location of the CPU. Now, if you combine that high base convexity with a washer mod or with a contact frame, you would actually end up with a little bit too centralized contact patch. But with deformation over time, if you have an Intel CPU that's been running for months and months with full ILM pressure, you may actually want to combine the high base convexity version with washers to get the best possible contact, just because the deformation can become so massive.
So I know that this is a lot to unpack, especially for people who just want to mount the cooler and not worry about things. But there's two ways to look at this. Number one is you can buy the standard version and be assured that you're going to get amazing temperatures regardless. Or if you're somebody who wants to experiment a bit, especially on the Intel side with the ILM washers, to get different types of mounting pressure at different points, you can do that as well and just find the solution that matches what you need. Because not all CPUs end up the same way after a couple of months. You have some which bow a little bit more, some which don't. And we've actually seen that before too, because we actually tested some of these contact frames that were claimed to reduce temperatures on some people's CPUs by multiple degrees, whereas on our processors, they hardly worked at all.
That's precisely the problem with deformation over time. So if you happen to have a CPU that has become permanently deformed, because part of the deformation is going to be plastic, it's not like they're going to spring back to their original shape once you take them out of the socket, then applying a contact frame or a washer mod may have limited effect. There should usually always be a little bit of improvement, but if it's enough to really substantially drop your temperatures, it's hard to predict, because it depends on factors like the actual amount of pressure you get from the ILM, and there are quite significant tolerances on that. It will depend on factors like mounting pressure from the heatsink, backplate stability, all that kind of stuff. But the bottom line is, if you have been running an Intel CPU without washer mod or contact frames for several months, then you're probably better off going with a high base convexity cooler.
Yeah, and the other thing that we have to mention is this washer mount. These washers do not mount to your standard cooler mounts. These washer mounts are under the ILM.
Yes, exactly.
And that adds a little bit more complication, but it's really no more complication than a standard contact frame gives you, where you have to physically remove the ILM. So we've got 3 different types of coolers, all of which have the same hardware, but each of which is very specifically targeted. Intel, AMD, and a very more all-in-one solution. And also, maybe before we get into the temperatures, why is it maybe a bad idea to be focusing just on the flattest base possible?
We often hear comments like, the base is not flat. What's wrong with your cooler?
Yes.
I forked up 100 for a cooler and it's not flat.
Yeah.
What's going on? Flat is not good.
As we can see here.
Even for AM5, there's a reason why we're pushing out a low base convexity version and not a flat version, and that's for a couple of reasons. One is that even the AM5 CPUs are slightly concave, so a totally flat cooler would not have good contact. And the other reason is manufacturing tolerances. There's a certain variability to the exact convexity or flatness you can produce. So if you aim for just flat, you will end up having some outliers that are slightly concave, and if you have a concave cooler, that's usually not going to give you a very good result.
So, okay, let's talk about where we are now with performance.
Yeah, so the biggest improvements from the socket-specific optimization are obviously when you don't use these mods we include to improve contact. So that would be without offset mounting on AM5 and without the washer mod on Intel. And in this case, we can see that we have around the green one is the standard medium base convexity version, and then we have a little bit more than 1.5 degree improvement by going from the regular medium base convexity to a low base convexity version. To some people, 1.5 degrees may not sound much, but in high-end heatsinks, squeezing out a degree or even 0.5 degree requires a lot of work. So if we see something like a 1.5 degree improvement, this is massive for us. And this is exactly the reason why we decided to go into all this admittedly cumbersome differentiation between the 3 different versions, because we spent so much time optimizing this cooler that it would be just a shame to waste 1 degree or more just due to non-optimized surface contact. But I think it puts that 1.5 degree improvement into perspective a little bit, because we've been working so hard creating new fans, adding extra heat pipes, optimizing the fin stack for like contact neutral 2.5 degree improvement, and then wasting 1.5 degrees for poor contact would feel terrible.
It would be, it's really a holistic approach to heatsink design. But it also shows why you can't just slap any fans onto any heatsink. They have to be designed together.
Totally.
So speaking of the fans, I want to talk also about sort of where all these realizations have brought you into a new generation of 120 millimeter fans.
Oh yeah, this is news we're breaking here this year at Computex. We've been talking about the 140 millimeter version for a long time, but we've applied the same design principles, the same design approach to a 120 millimeter unit as well.
There we have this.
Yes.
And we have the
standalone fan as well.
Okay.
So you can see it has the same progressive bent impeller design that we have on the 140 millimeter version, the same centrifugal turbulator hub. We talked through all the features last year, so I'm not gonna bore you with them again. The bottom line is that we're seeing a nice extra improvement over the existing award-winning A12 fan. We have some graphs over there. So we're seeing around 10 to 12% more flow through a heatsink or through a radiator. So that's quite a substantial improvement.
And that's not just your raw CFM, that's restricted CFM, which is even more impressive.
That's measured on the application, noise normalized. So we're really apples to apples and not giving you some free air figures that don't mean anything at all.
So what are you targeting? Because I also noticed that you're not doing a lot of things here that a lot of other manufacturers are doing with their 120 millimeter fans, which is adding to the thickness. How have you compensated? Because of course the thickness does help with static pressure and things like that. So how have you compensated for that without increasing the thickness, without getting into that, hey, you might have some issues with mounting?
Basically, it's the similar blade design tuning measures that we have done for the 14 centimeter. So it's the progressive bend impeller, centrifugal turbulator hub. You can also see that it's got those small winglets that we introduced for the 140 centimeter version. So it's just a newer generation of blade design with optimized profile, optimized feature set that enables us to perform a little bit better than the existing A12.
And now, when we're looking at this, just for the fan itself, because we're going to talk about a new cooler, 120 millimeter cooler very soon, what are we looking at for potential rollout of this? Or is this one of these things like, Half-Life 3, it'll be done when it's done?
Knock on wood, we want to have it out in Q1. I mean, it's with D15 G2, like it's being packed and shipped, so nothing should go wrong at this point. With this one, we're still finalizing some stuff, but I'm pretty confident that we're going to have it out in Q1 next year.
And then we have a new dual tower 120 millimeter cooler that's coming out based around this fan. Do you have a name for this yet?
It doesn't have a name yet. So there's really no, just internal working titles. But the idea is very similar as with D15 G2, that we want to make use of that nice new fan we have. So we have better PQ characteristics on the fan that enable us to optimize the fit stack for it, fine-tune it to work with the increased pressure level we can get for the fan. We've also increased the heat pipe count from 6 to 8 like we did for D15 G2. And the net benefit for the customer is going to be that this one is going to deliver roughly D15 G1 level performance, but in a 120 millimeter form factor.
So, and you would be planning all the same advances that you've made with the D15 G2, like for example, very customized mount per socket, et cetera, or are you really planning on keeping those features for your flagship?
Honestly, this is something where we will also have to wait and see a bit how the market reacts to that, how customers react to that. If there's too much customer confusion, or if the feedback is very positive, then it's something that we can gladly roll out to more coolers. And of course, we'll also have to see how the general platform situation will develop with a new socket arriving from one of the major players. So yeah.
Yeah, it's going to be interesting to see what he's actually talking about, what Arrow Lake S brings to the table a little bit later this year. Because if rumors are correct, Intel is also going with a chiplet design. And if Intel's going with chiplets, and if AMD is going with chiplets, it's going to be a nightmare for cooler manufacturers who might not be sort of using all of these realizations that Noctua has had over the last year plus. So the other thing that I just want to mention very, very quickly is that a little birdie tells me that you might have a different type of cooler here that might be more based off of liquid. Absolutely,
there's liquid cooling here at the booth. We are showing a Thermosiphon prototype. It's actually a two-phase Thermosiphon, so I guess most of the viewers will be familiar with the basic principle of Thermosiphons, where you heat a working fluid and create circulation due to density differences in the working fluid. And with a two-phase Thermosiphon, there's a phase transfer involved in the process. So in our case, we have the fluid going over the CPU, evaporating, vapor stream going up through a tube. We have the prototype on display over there, up into the top-mounted radiator or condenser, as it's better called in this case, where the fluid cools off, condenses, and then returns through the liquid flow line back to the evaporator to evaporate again. And this way, we have a fluid cycle without any moving parts. So there's no pump involved. But we're still targeting AIO level performance, and we're targeting AIO level look and feel. So it looks very similar to an AIO, it will install very similar to an AIO, it won't take up a lot of space around your CPU socket, it won't limit your RAM compatibility.
But the other thing that we have to remember, it might be AIO level performance, but it's without a pump.
Exactly.
So it's very, very quiet, especially considering it's paired up with Noctua fans.
So there's still a lot of work to do, and that's why we don't give an ETA at this stage. We also don't give a pricing prediction at this stage. It's a development project, and we've heard your feedback. We're trying not to put things on the roadmap where we're not very confident that we can stick to the announced schedule.
Yeah, because I was actually talking to Jacob a little bit on the side, just saying some of the concerns that we've had with Kalios, and Noctua understands all of those, which is why this is purely a developmental vehicle. This is not, at this point in time, a final product. This is using their experience to create something that's very, very unique and something that Noctua can use to expand their product profile beyond the air coolers that you see here.
Yeah,
and to me, that's so exciting.
I absolutely think that the idea of having the convenience and the clean looks of AIOs, the performance level of AIOs, without all the drawbacks, it should be a compelling offer. I mean, you don't have to worry about pump failure, you don't have to worry about vibrations, you don't have to worry about pump noise. So yeah, I'm very confident that this is a highly interesting path to pursue.
So a lot of interesting stuff at Noctua. We're finally getting the new D15 G2. We're eventually going to get a 120 millimeter cooler that hopefully will mop the floor with all of these very, very budget-focused solutions. Of course, there's always place for those budget solutions in every single market, but if you want the best of the best and you want the warranty and the support going into the future for future sockets, you've got what's in front of us and what might be coming on the sealed liquid loop side. So anyways, I'm Mike with Hardware Canucks. Jacob, thank you so much.
Thank you very much
Can't wait until what we see next year.
It's always a pleasure having you.
All right, take care, guys. Have a good one.